Lesson 25, Section 8.4, talking about rotations of axes. Now, this is the last section of conics, and what we're really doing here is we're taking a look at all the possible ways that we can see conics in a generic equation. So, if you look very closely at this, we'll notice that we have the general equation of a conic such that these things are specifically parallel to the x or y axes. Again, so far that's all we've worked with. Well, when we talk about rotation of axes, we want to be able to see this thing not necessarily parallel to either axes. So, you have ax squared plus cy squared plus dx plus ey plus f equals 0. And again, this is any generic equation of a conic. Now, we can actually determine the type of conic. Okay, the graph of the equation is a parabola when AC equals 0. Now, why does that make sense? Well, if C is 0, then I have ax squared plus dx plus ey plus f is equal to 0. Well, if that's the case, again, if that's the case, then clearly I can complete the square on the x's and get the x squared term, okay, the x squared term equal to a single y. If my a was 0, well, then I would just have this thing. And again, now we have the y squared variable, okay, and my x is going to be a single power. Now, so it makes sense for AC equal to 0, giving us a parabola. Well, let's talk about the ellipse. Okay, and we have an ellipse when A times C is greater than 0. Now, why does that make sense? Well, if this is positive and this is positive, then the two multiplied together will give me a positive number, and that's an ellipse. If they're both negative, well, then I can both move those as well as these pieces all the other side, get everything to be positive, and I have the same situation. Okay. Now, the last case is when the hyperbola. Now, the hyperbola is when A times C is less than 0. Well, that's just obvious because, again, if this is positive and this is negative, then the two multiplied together will give me a less than 0, and it must be a hyperbola because I'm going to have a x squared something or other minus y squared something or other. So, with that being said, we now have a way to determine any equation in this form. Okay, what kind of conic it is. Now we're missing a letter here. Ax squared plus cy squared. There's a b missing. Well, we're missing a b because up in this equation here, we didn't have a case for xy. Now, this is the general second degree equation in two variables. What that means is that I have ax squared plus bxy plus cy squared plus dx plus ey plus f all equals 0. Now, when I say this, what I really mean is that xy nearly wholeheartedly on its own determines our rotation. Now, it's unfortunate that it doesn't do it without any extra help. Because depending on what this is, and depending on what this is, depending on what this is, all three of those pieces together will tell us our kind of shift in terms of x. Likewise, with this, this, and this, it determines our shift in terms of y. Well, the next set of information, do not try to understand where it necessarily comes from. If you want to see that, I can explain that in class. For us, in terms of the understanding, all you need to know is that there is a specific rotation of the graph that we have. Again, this graph up here corresponds to the x and y axes, the parallel to the x and or y axes. This one here is not parallel to the x or y axis. It's parallel to something else that I have no idea what it is. The next set of formulas and equations actually provide us with a way to determine how it's rotated. Okay, now, let's slowly go through this piece of information right here. Suppose the x and y coordinate system and the x prime y prime coordinate system have the same origin, and that alpha is the angle between the positive xy or x-axis and the positive x prime axis. If the coordinates of a point are xy in one system and x prime y prime in the rotated system, then this xy is equal to this information, and this x prime y prime is equal to this information. Now, all we're saying is x is being shifted to x prime in a specific way, and vice versa for y. Let me draw a picture to help you understand what I mean by all of that information that's being said. Okay, here's my xy. Yes, that's my xy coordinate system, no big deal. What this block says, what number 3 is really saying, is that I have an angle alpha. And that angle alpha determines an x prime axis. Now, if that angle alpha is shifting this set of axes right here over to there, then this set of axes will also have to be rotated by a measure of alpha, give or take. So if I can draw this perfectly right, this is going to be perpendicular to that. There's my y prime axis. Now, let me get out a red pen here and show you what is really happening. What we are saying is I have a specific graph on the x, y coordinate plane. But the issue is it's been rotated. So I'm going to go ahead and keep circling this ellipse that I'm not going to draw here. What I'm going to do is I'm going to rotate this ellipse. So it's now being rotated around the x, y prime, or x prime, y prime axes. So you'd see something like this. And now it is a little off, but you can see this is an ellipse in this coordinate plane, the x prime, y prime plane. Whereas in the ellipse that would be on here, sits more like this. I'm going to switch back to black and see if I can do this correctly. Sits more like this. So what we want to be able to do is to determine, first of all, first thing is this thing going to be an ellipse, a parabola, or a hyperbola? Second thing we want to do is be able to sketch a graph that looks like this. Now, in terms of this section and in terms of what I expect you to be able to do in this section, it's not going to be as drastic as what's in your homework and what's overall in the notes. But you need to be able to apply the formulas. Now, let me go back to the paper, and again, I'm going through all the explanation in this video. We will actually approach the problems in the next video. So the rotation theorem for conics. Given that I have this particular conic, okay, x squared plus bxy plus cy squared, blah, 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 and let alpha be the angle of rotation, this statement right here is true. Cosine 2 alpha is equal to a minus c all divided by b. So these three pieces of information actually will be able to give me my rotation angle, alpha. Now, the equation of the conic in the rotated coordinate system will be this. What I've done, going from here to here, down to here, is I'm using these formulas, okay, which is why I'm not showing it. I'm using these formulas to replace the x's and y's up here to get the x primes and y primes down here, where the alpha, okay, will be my angle of rotation, where my coordinate axis will now be, such that all this crap, okay, this particular ellipse will now look like this in the new plane, as opposed to this, okay? So, with that, what we're going to do very carefully is simply use the cotangent of 2 alpha is equal to this, manipulate it to get a prime, c prime, d prime, e prime, and f prime, and then draw my new graph. Okay? So, with that all being said, we'll go ahead and take this first two examples here in the next video.